Okay, so example B, hopefully you've already tried it and are just checking it out. So first thing we gotta look is points of discontinuity. So we gotta look at the denominator and factor that or see when it'll become 0. But if you try to factor this and you think what multiplies to give me positive 1 but adds to give me 0, because our B term is technically 0, you'll never think of a number because it's imaginary. So there's no real number that can make this 0. So there are no points of discontinuity. So it'll be a continuous graph. So that means our domain will go from negative infinity to infinity, meaning the graph will, I don't know the exact shape, but something like this maybe. It'll just go forever and ever and ever left and right. The other way to think about it is I can plug any number from negative infinity to infinity in for x. So no points of discontinuity, domain, there we go. So since there's no points of discontinuity, we don't have to worry about types. Now the y-intercept, remember, and by y-intercept I mean x-intercept, remember that for your x-intercept, the y value is 0, right? So if you kind of think 1, 2, 3, negative 1, negative 2, the y value is 0. So y is 0, and we only care about the numerator. So the x-intercept is at 5, and the y value is 0. Now for a y-intercept, the x value, if you think about that, will always be 0. Oh, and then I'd do that, right? So the x value will always be 0, so we take our function and we replace 0 in for all the x's. So 0 minus 5 is negative 5. 0 squared plus 1 is 1, which is negative 5. So done with B. Right, C, points of discontinuity. So we're going to look at the denominator and make sure that it never becomes 0. So we're going to have a gap at x equals 4. Now, we've got to see what type it is by seeing if it cancels out or not. So I'm going to hurry and factor this. Oops, factored it incorrectly. If you have questions on factoring still, please email me. I'm assuming you can factor pretty solidly by now. So that x minus 4 actually cancels out. So our point of discontinuity at 4 is a removable, also known as a whole. Okay? Now our x-intercepts, remember, if you remember from the notes, we don't care about that stuff that got canceled out. It's not going to be part of our graph. But 0 equals x plus 1. Whenever we're dealing with an x-intercept, we're going to have a number in the x spot and 0 in the y spot. And just the different for the y-intercept. All right, so we're going to have negative 1, right? And 0. Now the y-intercepts, when we take that equation and we replace every 0 with every x with 0, sorry. So 0 minus 0, we have negative 4, which is negative 4 divided by negative 4 is 1. Now our domain is usually negative infinity to infinity, meaning we can plug anything we want for x and it'll give us an answer, but we actually have a gap, right? We have a gap at 4. So negative infinity up to 4, we hop on over 4, there's a gap right there, and then keep going. So you can plug in any number for x you want and get an answer, except for at 4. So as you see in the domain, we just hop on over 4. The parentheses means not included. Okay, D. I'm going to factor this guy. Alright, so points of discontinuity, I have one at 4, one at negative 4. They're both non-removable. The x-intercept kind of seems like there's not one, because if I try to set the numerator, nothing's going to happen. Okay, now my denominator is how I find my y-intercept. So 0 equals 1 over 0 squared minus, y equals 1 over 0 squared minus 16. So my y-intercept should be at 0, comma 16. What the? Sorry. That's negative 1/16. Sorry. 0 minus 16 is negative 16. 1 over negative 16 is my y-intercept. Now I want to show you something about your x-intercept real quick. So we had something weird kind of happen there. So if we graph this on the calculator, as long as you put it in correctly, it'll do what we want it to do. So I'm going to put in that original function that we had, and I'm going to hit graph. So some strange things are happening, right? So we can zoom in and see the y-intercept does hit probably at negative 1 over 16, and then we can see some weird asymptotes. Now, there's a point there, but if we zoom in, we can see that this graph, that point's just kind of marking where I'm looking at, but the graph never, ever, ever touches. If I keep going this way, oops, sorry, I'm hitting on the graph weird. The more I zoom in, the more I can see that we're actually never touching, the x-intercept. So I can just move that point and you can see it kind of jumps around. Yeah, we never touched the x-axis, so maybe cool, kind of weird, but there's no x-intercept, okay? Never touches the x-axis. Okay, so domain. I don't know if you noticed, but that graph went left and right a long ways. But at negative 4, some weird things were happening. At 4, so look at this domain. I'm saying, hey, choose any number in between negative infinity to negative 4. Plug it in for x, you'll get an answer. But negative 4, we're going to jump on over that. We're going to jump over 4. So anything between negative 4 and 4, and then anything from 4 to infinity. Okay? So all I have to do is take my points of discontinuity and jump over those, because those are gaps. So let's look at the graph one more time. Yeah, at negative 4 and 4, there's jumps, right? So we have these gaps. If you look at that little dot, right, it goes up, 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 up. Yeah, my finger's too fat, but you can see it just jumps, goes left and right forever, except for where it jumps over that negative 4 and, oops, negative 4 and 4. E. I'm going to quickly factor this guy. Oh, sorry, factoring wrong. Okay. There we go. So we have points of discontinuity at 2 and 3. Types, well, they didn't cancel out, right? So they are non-removable. They're staying there. X-intercept, we just take the numerator, set it equal to 0. X is equal to negative 1 for our x-intercept, and our y was 0. The y-intercept is going to be 0 plus 1, which is 1. 0 squared minus 5 times 0 is 0. Plus 6 is 1/6. So y equals 1/6. X comes first, x is 0, y is 1/6. Domain. We're going to go from negative infinity up to 2. We're going to hop on over 2. But in between 2 and 3, we can use those values. But we're going to hop over 3 all the way up to infinity. All right, and F, here we go. Point of discontinuity. It's going to be negative 2. Now, I'm going to factor the numerator. You're going to notice that that cancels out, which means it is, which means it's removable. I could cancel it out. So technically I'm left with y equals x, right? Okay, so my x-intercept, I'm going to replace my y was 0. My x is already alone. At 0, 0, the graph is going to pass through, so the x-intercept's at 0. Now, when I try to find my y-intercept, remember the y-intercept happens when x is 0, which, I mean, we kind of already have the x is already 0 there, so I kind of already have a hint of where my y-intercept will be. But I'm going to remind you, to find your y-intercept, you replace all the x's with 0. So we have 0 plus 0, which is 0, 0 plus 2, which is 2, 0 divided by 2 is 0, so the y-intercept's also at 0. Our domain, every x value except for our point of discontinuity. So it's continuous except for at that point. So from negative infinity up to negative 2, we'll hop on over negative 2, go all the way up to infinity, boom, 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 we're done. Now, if you need more examples, let me know, but you have your homework to practice. I'll post a key. Take a look here. You can use the graphing calculator. Make sure you put the numerator in parentheses and the denominator in parentheses. But the point of me teaching you this is you can go really quick and not have to spend time typing those in. So hopefully this helps. If not, let me know.